Welcome back, students. We'll be looking at section 3.1, terminology for linear equations and rectangular coordinates. Our first two blanks will have the term line graph. A line graph shows changes and trends of data over time. So let's look at an example and answer some questions from this line graph here. You'll notice on the vertical side, we have the rate, the percent. Okay, so this is the data that was collected. And then on the horizontal line, we have the years. This is the time that this data was collected over. Now we have questions about this particular graph. Between what years does the graph indicate an increase in rate? So the first thing we need to do is find where our line on the graph actually does indicate an increase. And we have two of those. We have one here, and then we have one here. So our first incline, our first increase, started in the year 06. And it went until the year 08 before it started to change direction and decline. So our first answer in this blank is going to be 06 to 08. Our next incline, our next increase was from 09 to 11. So we're going to include that, 09 to 11. Now it asks us a different question. It says, well, what was the change between 06 and 08? Well, the rate in 06 was at just below 6 here. In 08, it was at the 8 here. So I'm reading these numbers to the left here. So a difference between 8 and 6 is 2%. Now that red dot is not perfectly on that 6. So I'm going to say it's roughly, so I'm going to use the squiggly equal sign, a 2% increase. So I'm going to use a positive 2 rather than a negative since it was an increase. In 09, we started at 7 here, and then in 11, it finished just below 8. So again, we have roughly a 1% increase from 7 to just below 8 is roughly 1%. Now let's look at when we have decreases on this graph. I'm going to change colors here. So between what years does the graph indicate a decrease in rate? We have two. We have a section here, and then we have a section here. So that's between 08 to 09. And then our second one was from 11 to 12. Now we need to answer what was that change between 08 and 09? Well, it started at 8 here. And then it decreased to just below 7. So I'm going to say we had roughly a 1% decrease. To indicate that decrease, I need to have a negative in front of that 1%. That indicates a loss. Okay, from 11 to 12, we started at just below 8 and ended at just above 6. So I'm going to say roughly a loss of 2%. Now let's look at writing ordered pairs from a line graph, also known as coordinates or points. So you can interchange ordered pairs, coordinates, and points. Those terms mean the same thing. So for the first blank, we're going to have horizontal. The horizontal line represents the x-axis. The vertical line represents the y-axis. Now we need to fill in the ordered pairs from the line graph above. I'm going to scroll up. We're not going to be able to see our lines that we need to write our answer in, but I'm going to write them over to the side and then we'll fill in our blanks. The x-axis is here. And then remember that the y-axis is the vertical, so it's here. Okay. Now the other thing to notice is that the y part of your coordinate is always the second number listed, and the x part of your coordinate is always the first number listed. So we're going to list our coordinates over here to the right, and then we'll transfer them to our blanks that I provided you. All right, so our first one, the x is 06. Our y is 6. That's our first coordinate. Our second plot is 07. And the y part of that is 7. Our third plot is 08. And the y section of that is 8. Our next one is 09. Probably should have written smaller, huh? And then it is connected to the 7 over here. Our next one is going to be 10. Let me switch colors. I'll draw a line here. I'll write a little bit smaller on this grouping. And it connects to just above 7. So, let's see here. I'm going to say, or actually just on 7, I'm going to say 7 again. All right, let's make that blue so we don't get confused. Okay, and then let's see here, 11, we went to roughly 8. So I'm going to put that. And then our last one we have in the year 12. And it was roughly 6. So that's how you write out your coordinates. All right. So let me fill ours in over here. On my notes, I have slightly more accurate numbers that I'm going to jot down in here for you guys. So I have 06, comma, 5.8, because it wasn't quite to the 6. It was almost to the 6, but not quite. Our next grouping was 07 to 7. Then we had 08, 8. Our next one was 09. And it was roughly 6.8. Then we had 10. 7. Then we had 11 and 7.6. We've got 12 and 6.4. Okay. Now, the other coordinates that we formed before we wrote these in, they're the exact same. They're just not as accurate. I tried to, when we were filling in these blanks, be a little bit more accurate about where those dots were. But you get the idea of how to find them. Your X part, your horizontal number goes first. Your vertical number goes second. That's your Y. Let's now look at linear equation in 2 variables. So the graph of a linear equation. Remember, a linear equation is the equation of a straight line, right? Because it has the word line in it. So the graph of a linear equation in two variables is a line. And more specifically, it's a straight line. We've talked about that in a previous video. All right, so linear equation in two variables written in standard form. We have ax plus by equals c. The x and y represent the values of ordered pairs, so coordinates. The a, b, and c represent real numbers, okay? So keep that in mind as we go through these examples. Standard form examples. We have 2x plus 3y equals 16. Important, the x and the y are on the same side of the equation. So notice that in our standard form, the x and the y are both on the left-hand side. They're together, basically. That's important. That's what dictates that it's standard form. So we have 2x and we have 3y here. They're on the same side. Our next example has 7x minus 4y equals negative 2. So again, they're on the same side, so it is standard. Our next one has x plus 5y equals negative 8. They're together, so that's standard. Now let's look at a non-example. We have y equals 4x minus 5. This is still a linear equation, but it's not in standard form because the y and the x are not on the same side. They're on opposite sides of the equation. Then we have y equals 3.5x plus 1. Again, this is the equation of a line, but it's not in standard form. X equals 2y minus 10. It's the equation of a line. It's a linear equation, but they're on opposite sides, so it's not in standard form. Writing solutions as an ordered pair. Write the solutions x equals 2 and y equals 4 as an ordered pair. So remember, our ordered pair has x comma y. The x is always listed first. So if our x is 2, I'm going to say 2. If our y is 4, I'm going to put the 4 here, and that is our ordered pair. In this ordered pair of 2, 4, a solution, or is, excuse me, I read that wrong. Is this ordered pair 2, 4 a solution to the above standard form equation examples? So I took the examples that we looked at above and I brought them down so that we could go through and learn how to determine if they are in fact solutions. You've already done a similar form of this with finding whether or not one number was a solution to an equation. Now we're going to find out if these two numbers are. But we can do it at the same time, so we're not going to have to work out two different problems at this point. So I'm going to plug in the values for x and y. So I have 2 times, my x value is 2, plus 3 times my y value, which is 4. Because remember, the 2 is in the x location, the 4 is in the y location. 2 times 2 is 4. 3 times 3 is 12. And I bring down the 16. 4 plus 12 is 16. And I have the 16 on the right-hand side. So is that a solution? Yes, they are solutions for this standard form equation. Let's look at the next one. Plug in my x as 2. My y as 4. And that equals negative 2. 7 times 2 is 14. 4 times 4 is 16. So I have 14 minus 16 equals negative 2. I'm going to change that. Keep it, change, change. So 14 plus negative 16 is negative 2. So that is a solution for this equation as well. Let's look at this last one. X is changed out for a 2. And y is changed out for 4. So I end up with 2 plus 5 times 4 is 20. 2 plus 20 is 22. Does 22 equal negative 8? No, it doesn't. So that means this coordinate, this ordered pair, is not a solution for this standard form equation. Completing ordered pairs. So they're going to give us one part of the coordinate. And you'll notice in number 1, we have a -1. We have our x value, but we don't know our y value. That's what we're going to be trying to find. So to do that, we need to plug in our x value. So 2 times -1, rewrite the plus 3y equals 16. Now you'll notice we only have one variable left. We're going to solve for that variable to find out its value. So 2 times -1 is -2. Rewrite the rest of the problem. I'm going to add 2 to both sides to get rid of it. I get 0 plus 3y equals 18. 3y equals 18. Now I'm going to divide both sides by 3. Divide by 3. And I get y equals 6. So I'm going to plug 6 into my blank here. So our coordinate that we were looking for is -1, 6. Let's look at number 2. I have x plus 5y equals -8. This time they give us our y and we're missing our x. So I'm going to plug in the y value. I have x plus 5 times -2 equals -8. X plus 5 times -2 is a -10 equals a -8. I'm going to rewrite this so I know how to move that -10. I'm going to undo the keep it, change. I'm going to go the opposite direction. So I'm going to keep my x, change my plus to minus, change my 10 to plus. Now I'm going to add 10. Add 10. I get x plus 0 equals 2. So x equals 2. And I will plug 2 in my coordinate answer. Number 3. Y equals 7x minus 2. This time we have the x. We're looking for the y. So y equals 7 times 2 minus 2. Y equals 14 minus 2. So y equals 12. Put my 12 in my answer. Number 4, we have our y, but we're looking for our x. We have y equals 3x plus 4. So I know my y this time. I'm going to say -11 equals 3x plus 4. Subtract 4 from both sides. I get -15 equals 3x plus 0, which is -15 equals 3x. Divide both sides by 3, and I get x equals -5. I'm going to put -5 in my blank. All right, so now we're going to look at completing tables of values. In your homework quizzes and tests, you'll have where they give you a whole table of coordinates, and then they'll want you to find the missing parts of that table. So our first one we're going to look at is right here. They give us the x, we're looking for the y. So I'm going to plug in my x. I have 2 minus 2y equals 8. Subtract 2, and it was 0 minus 2y equals 6. So that's a -2y equals 6. Divide both sides by -2, and I end up with y equals -3. So I have a 2, -3. I'm going to put my -3 here. Using the same equation, I'm now going to use this grouping. Again, we know our x, it's 10. Subtract 10 from both sides. I get 0 minus 2y equals -2. So -2y equals -2. Divide by a -2 on both sides. And I get y equals 1. So our coordinate is 10, not a -1, positive 1. So I'm going to put a 1 here. Our next grouping is this one. We know our y this time instead of our x. So let's plug that in. We have x minus 2 times 0 equals 8. X minus 2 times 0 is 0, and that's 8. So x actually equals 8. So I'm going to put my 8 here, and the 0 was my y. Last one for this particular chart. Using the same equation, I know that my y is a -2 in this scenario. So I have x minus 2 times -2 equals 8. -2 times -2 is a positive 4. So I'm going to put plus 4. Subtract 4 from both sides. I get x plus 0 equals 4. So x equals 4. So 4 here and a -2 here. And we're done with that particular problem. Now let's look at another one. In this one, we have x equals 8. So the way we need to solve this particular problem, because we don't have a y for us to plug in, is we would set up our equation like this. X plus 0 times y equals 8. Because 0 times y would be 0, and that would make that y non-existent, right? So we're not adding anything to the equation as far as value goes. We're just giving a placeholder for that y so that we can plug in. But again, because we have it multiplied times 0, we're not changing the value. It's just giving us that location to plug in that number that we need to be able to find x, okay? So our first y value that we're going to plug in is 5. So we have x plus 0 times 5 equals 8. 0 times 5 is 0. So this just demonstrates that I didn't change the value of anything. I just gave us a location for us to plug in that value so we could find x. So, oh, interesting. X equals 8. Okay. That's interesting. Well, let's look at the next one and let's see what happens. I have 0 for my y this time. So x plus 0 times 0 equals 8. So x plus 0 equals 8. Interesting. X equals 8. Okay. So I have 8, 0. I'm going to put my 8 here. Now let's do it one more time. X plus 0 times -2 equals 8. Okay. X plus 0 equals 8. X equals 8. Well, that's weird. Each time we plugged in our y, we ended up with 8 as our x. Well, actually, it's not weird. And here's the reason. They already told us what x is. They said x equals 8. So when you come to a problem like this, if you remember, then you can just say, oh, well, if x equals 8, and just fill in 8 for all your x values. But you got to remember that. But that's only when there's no y involved as far as your equation goes. So if they have a y in here, you can't do that. It's only if it's just x equals a number that you can do that. If you don't remember, set your problem up like this, like I did here, and solve and get your x, and it'll trigger your memory of, oh yeah, that's when it's all the same number, the number that they already told us. We don't need this fourth box here. We're done with this one. Now let's look at y equals 2. So we're going to do the same thing. We're going to, since we don't have an x here, we're going to put a 0 times that x, just so we have a place to plug in. So our first x is a 3. So 0 times 3 plus y equals 2. That gives me 0 plus y equals 2. So y equals 2. I wonder if we're going to end up with the same situation that we had above, except now we're talking about our y. So I'm going to put 3, 2. But let's test it just to make sure. My next grouping has my x as a 1. So 0 times 1, or here, let me change colors on that so we can tell the difference. 0 times 1 plus y equals 2. I get 0 plus y equals 2, so y equals 2. It looks like we're going to end up with, I put a 0 instead of a 2. It looks like we're going to end up with the same scenario, but let's do our last one just to make sure. I have a -5 for my x this time. 0 times -5 plus y equals 2. 0 plus y equals 2. Y equals 2. So it did. So we have the same scenario here. So let's compare the two. In number 6, we had x equals 8. And because we didn't have a y in that equation, we ended up with all our x value coordinates being an 8. In number 7, we had y equals 2. We didn't have an x in that equation. So we ended up with all our y values equaling 2. Now here's something I want to point out a little bit early, and we'll come across this later as well. When you have an equation like this, x equals 8, you're going to have a vertical line at the location of 8 on your x-axis. So just remember, you're going to have a vertical line. When you have y equals 2, you don't have an x in your equation, it's just the y, you're going to actually have a horizontal line where it crosses your y-axis at 2. And again, we'll talk about that later more, but I just wanted to kind of introduce it to you so it's not something that you haven't heard before. All right, so let's label our parts of a graph. We have our y-axis right here, and then we have our x-axis here. So the x-axis is horizontal. I'm going to write that word, horizontal. Our y-axis is vertical. Now we're going to look and notice that we have what's called 4 quadrants. These quadrants move counterclockwise in this direction, okay? So we have quadrant 1, then we move to the left, we have quadrant 2, we move down, we have quadrant 3, we move to the right, we have quadrant 4. Let's label what the coordinates would look like in each of those quadrants. So if I have a coordinate in this location, in this side of the graph basically, so it could be anywhere in here, any coordinate in here, my coordinates are going to have certain signs, certain positive, negative signs. Let me get that out of the way. They're actually going to be positive x and a positive y. So you will have both numbers are positive in quadrant 1. In quadrant 2, our x value, because we've gone this way into the negative region, our x value will be negative. Our y value will still be positive though, because we're still above and we're still in the positive region of that location. Quadrant 3, we are in the negative region of x, so that's going to be a negative. We are also in the negative region of y, so our y value will also be negative. Quadrant 4, we are back into the positive location of x, so we're going to have a positive number. but we're still in the negative region of y, so that's going to be a negative. I wanted to give you this as a key that you could look at so that when you're finding coordinates or you're plotting coordinates, you can look at this pattern and see if you've made an error. Sometimes we'll plot in the wrong location because we forget about the signs or something like that. And if you look at this, this will help you to recognize, did I plot it in the right quadrant, and go from there. All right, so let's look at plotting these ordered pairs. So I'm gonna label them X, Y, X, Y, okay? So I'm gonna label all my X's just to help me remember which represents which. All right, I'm gonna pick a different color for us plotting them. All right, so for letter A, we have the coordinate 2, 3. So I'm gonna locate 2 on my x-axis first. That's right here. Here's my 2. From that location, I'm now gonna find my y, which is 3. So I'm gonna go up 3. So I'm right here, okay? So we went this direction 2, and then we went up 3 to find our coordinate A. Okay. Now let's look at B. I have a -5, so I'm going to go this direction to -5. But then I have a +4, so I'm going to go up 4. And my coordinate is right here. So that's letter B. Now the blue line and the green line that I have on here, you're not going to draw that. You're just going to plot your coordinate. I'm just doing that so you can see how we're finding the coordinate. All right, our next one is C. We have a -3. So we're going to go to -3 right here. And then we have a -7. So we're actually going to go down this time instead of up. We're going to go down to -7. And here's our coordinate C. Our last one, D, we go to 8. So we're back on the positive side of the X. We're going to go to 8. And then we went down 4. And our coordinate is right here for D. Now, coordinate A is in quadrant 1. And notice both those numbers are positive, right? Just like we said, if they're in that quadrant, they're going to be positive. B is in quadrant 2. And you'll notice B had our X is negative, our Y is a positive, just like we said the quadrant would be. So I'm just showing you that so that you can see what I was saying about using that as a key to kind of double check yourself. All right, so that is the end of this terminology section. Let's look at our quote. The enchanting charms of this sublime science, mathematics, reveal only to those who have the courage to go deeply into it. Carl Friedrich Gauss. All right, guys, hope you're having a great day. I'll see you in the next video. Bye.